number 6. So y equals 2x squared plus 4x all over e to the x in the first derivative test. So y prime is going to be 4x plus 4, right? And then e to the x minus e to the x to 2x squared plus 4x, right? Okay, and then all over e to the x squared, right? So let's try to see or simplify this out. E to the x, right? And then 4x plus 4 minus 2x squared minus 4x. We're going to disregard the denominator because we all know that there's like no way that e to the x is going to be equal to 0. So let's just disregard that and then see negative e to the x. I'm going to not put the equal signs because that's not mathematically correct, but we all know what it means. And then negative 2x squared cancels out. And then plus 4 equals to 0, right? So negative 2x squared plus 4 equals 0, so negative 2x squared equals negative 4. X squared is equal to 2, so x is going to be equal to root 2 or negative root 2. Alright, okay. Or, yeah, let me just try to, okay. So these will be our candidates, and then let's try to do a sign chart of them. So basically, for the signs, we're going to be only considering this part right here. So we can just draw the graph of negative 2x squared plus 4 on this sign change chart right here. So that is a open downwards parabola. So we're going to have two x-intercepts right here, open downwards like that. So positive, negative, positive. So we have a relative min at negative root 2 something, and then relative max, oh, this is supposed to be negative, relative max at root 2 something, okay, and then we'll have to plug the values into y equation for this part. For negative root 2, I got negative 6.815, and then for root 2, I got the value of negative 1.65997. Y equals root of 1 plus x to the third, and using the second derivative test, y equals 1 plus x to the third to the power of 1/2. Y prime equals 1/2 times 1 plus x third, negative 1/2 times 3x squared. Okay, so 1 over 2 root 1 plus x squared times 3x squared. Okay, so when this is equal to 0, right? So let's see. This is equal to 0 or undefined when x is equal to 0, and then when x is equal to negative 1, right? So these will be our candidates, and then we're going to do y double prime. For this one, I would say still use, still calculate it yourself. So 6x, right? Times, okay, I'm going to leave out the 1/2 out here. 6x times, how about we do the product rule instead of quotient rule. So negative 1/2, 1 plus x to the third to power of 3 over 2, right? 3 over 2, and then 3x squared, and then 3x squared plus 6x, right, times 1 plus x to the third to the power of negative 1/2. Okay, so let's see when this is equal, or when you plug in 0 to this. Okay, and then what about negative 1? negative 1 gives us an error, so that probably means that the y double prime is going to be ending up with this as a denominator, which is probably why it gives us an outer bound at negative 1. So I think the only relative extrema that we have is going to be at 0. So relative max at 0 and then 0, 1, right? 0, 1 again. So this will be our answer. And number 8 gives us a polynomial. Okay, so let's just do the second derivative of this, or first and then second. 9x second minus 18x, right? Plus 8. Okay, and then let's see where this is equal to 0. I'm gonna say that this is equal to 0 when, or yeah, okay, when 3x, and then let's see, 4, 2, yeah, that works. Negative 6, yeah, and negative 12, okay. So 3x negative 2 times 3x negative 4 equals to 0. So x would have to equal to 2 over 3, or 4 over 3, right? So these are our two candidates, and then let's see our second derivative, which would be 18x minus 18, right? And let's just plug in these values to the second derivative. So 18 times 2 over 3 minus 18. That gives us 12 minus, 12 minus 18, or negative 6, right? So this is less than 0, and then y double prime of 4, 3 gives us 18 times 3 over 4. That gives us 6 minus 18, or 6, which is greater than 0, so positive. So we have a relative max at 2 over 3, and then, okay, or min at 4 over 3. Let's try to find out where these points are. I am getting negative 1 for this one, and then negative 6.556 for number, or for 4 over 3. Okay, and then moving on to 9. Y prime equals 2 ln x squared, and then 1 over x squared times 2x, right? So we get 2 ln x squared, or actually 4x all over x squared, and then we cancel out, so 4 ln x squared over 4. Alright, so we're trying to find when this is equals to 0. So let's see. Well, for this one, ln x squared is equal, or ln x squared is equal to 0, right? Ln x squared, when you think about it, ln x squared is actually never equal to 0 because it has an asymptote, right? Never mind. Ln x squared is actually equal to, so ln x is equal to 0 when x is equal to 1, so x squared needs to equal to 1. So x is equal to 1 or negative 1. But then I would say, yeah, that's right. And then we have our candidates here. Let's try to see when these are positive and negative. So negative 1 and 1, right? And then we're gonna put in 0. But then realize that 0 is not in ln's domain, so maybe like 1/2, right? So I'm gonna plug in ln of 1/2, or actually 1/4, right? Because 1/2 squared, and then times 4. Okay, so that gives us a negative, okay? And then let's plug in 2, so ln 4, that is positive, so that's that. And then ln of negative 2, which is also like 4, right? Because it's squared, so we're going to say positive here. So we can see that we have a relative max at -1 and then 0, right? Oops. Right? And then relative min at 1, 0, right? Okay, so moving on, negative sine x times x, and then minus, right? And then cosine x all over x squared. So negative x sine x minus cosine x all over x squared equals 0. Okay, so I'm going to use the calculator for this one, right? And then this is on 0 to 3 interval, so we can do 0 and 3. Okay, and I see that actually there is an intersection or a 0 from this line or this curve. Okay, so this is when x equals 2.798. Okay, so based on this 2.798, I'm going to see where the positives and negatives are. So before 2.798, the value is actually negative. And then after, after 2.798, it's going to be positive. So there is a relative min at 2.798. And then cosine 2.798 all over 98. That gives us a negative 0.337. Alright, and then moving on to number 11, we have a polynomial. Y prime equals 5x to the 4th minus 20x to the 3rd. Okay, and let's find out when this is equal to 0. So 5x to the 3rd and then x minus 4 equals to 0. So x equals to 0, x equals to 4. Okay, let's find the second derivative, which would be 20x to the 3rd minus 60x to the 2nd, right? So we can factor out 20x squared, so x minus 3 equals 0, even though this is not needed actually. Got confused. And then y double prime of 0 equals 2, 0, right? Which doesn't count. And then y double prime of 4 is equal to 20 minus 60 times 16. Okay, is 320, which is greater than 0. So there is a relative minimum at 4, and then 4 to the 5th minus 5, 4 to the 4th plus 20. So negative 236. Alright, and then moving on to y equals x squared ln x, and then using the second derivative test, so y prime is equal to 2x ln x, and then plus 1 over x times x squared, 2x ln x plus x equals to 0. So let's find out when this is equal to 0. So x 2 ln x plus 1 equals to 0, so x equals to 0, and then 2 ln x plus 1 equals to 0, so ln x equals to negative 1 over a second. Okay, and then let's just try to find that value. Well, e to the negative 1/2 would be equal to x, right? Okay. Let's see our second derivative now. So y double prime equals to 2 ln x plus 2 times R2 x times 1 over x, right? So 2, oh, just 2, okay. 2, and then plus 1, which gives us 2 ln x plus 3, right? And then let's try to plug everything in to see if they're positive or negative. So y double prime of 0 would give us 2 ln 0, or 2 plus 3, so 5, which is greater than 0, right? And then y double prime of e to the negative 1/2, we get 2 times negative 1/2, negative 1 plus 3, which is 2, greater than 0. So relative min at 0, and then 0, 0, and then also e to the negative 1/2, and okay, negative 0.184. Okay, and then just giving you a little bit of time to check your work, as I check my work too. So ln okay, got it. And then let's go to our second to last question, 13. Y prime equals 2. First derivative test, so we're going to take the derivative of this, or negative 4x, right? Okay, and then e to the negative 2x squared minus 8. This is equal to 0, or undefined, okay. Negative 4x over e to the 2x squared minus 8 equals to 0. Again, we're only considering the numerator because the denominator is never 0. So x is equal to 0. Let's see. 0. And then let's just plug in 1 to our first derivative, and then we get a negative number. Okay, and then we plug in, we plug in negative 1 and we get a positive number. So that means that we have a relative max at 0, 0, and then e to negative 8, right? Okay. Number 14, y equals x, e to the negative x in the first derivative test. Y prime equals to e to the x, right? And then I'm going to say minus x e to the negative x equals 0. So e to the negative x, 1 minus x equals to 0, right? And then we're going to say x equals to 1 is going to be our candidate. Okay, and then 1, let's see. And then this, we can see that this one doesn't matter, but this one matters, right? So we're not considering this one. And then this is a line with a negative slope that's passing through 1, 0. So it's basically like this, passing through 1. So positive, negative, right? So we get a relative max at 1, and then